what I want to do is go over what we have right now as a lead and copper rule and what we enforce in the state, and what are some of the upcoming changes that really can be published any day now. We're expecting EPA to have the final rule out within weeks to come, and hopefully this gives everyone a snapshot of what those impacts may be to our state and what types of regulations our public water systems are going to be held to. So what really is the lead and copper rule under the Safe Drinking Water Act? It is a rule that helps to add a layer of public health protection by looking at the lead and copper release levels in drinking water. The goal of the lead and copper rule of the Safe Drinking Water Act is to help us regulators at ADEQ's drinking water program to identify the need for a system to install corrosion control. So lead and copper samples for us are indicators that a system may need to do something to bring those levels back down. So that kind of brings us to two different talking points. In the Safe Drinking Water Act, particularly with the National Primary Drinking Water Standards, there are two different key, there's really three, but the two that I want to focus on today's presentation is the difference between a maximum contaminant level and an action level exceedance. So maximum contaminant levels, these are levels that EPA has derived a known toxicity value in a certain threshold to where known adverse health effects have been determined. And from there, the maximum contaminant level is derived. And this is what levels are used to help identify drinking water quality issues that may cause an adverse health effect. The differences between the maximum contaminant level and the action level exceedance really ties into that toxicity value. Right as of right now, there is no reference dose, there is no toxicity value determined for lead or copper in accordance to EPA, which is where Arizona Department of Environmental Quality gets their regulation and primacy from. So lead and copper rule has a standard called the action level exceedance. And so these two standards for lead and copper are a feasibility standard that EPA determined back in 1991 when the first lead and copper rule was promulgated to help states determine if corrosional treatment is required. These levels that are determined for both lead and copper, what we call ALEs, they are not used to determine if or when a public health outcome could occur, and they're not used to help determine if someone is exposed to concentration or a 90th percentile level above the action level, if their blood lead levels would be elevated. There are other sampling techniques that can be deployed to evaluate exposure assessments, but that's kind of outside the scope of my presentation, and if you have interest in it, please contact me and we can talk about that. So just kind of over history of the lead and copper rule. Like I said before, 1991 is when EPA established the first lead and copper rule. Over the last few decades, we had some revisions that helped really enhance and tighten the public health aspect of lead and copper releases through drinking water and premise plumbing. A lot of that entailed the water systems being more transparent with their customers, providing more meaningful and expedited public education, and also giving the states, such as ADEQ, more rule language to enforce treatment and to evaluate treatment to control for those lead and copper releases from premise plumbing. And right now, what we have to look forward to is the long-term revisions, which I'm going to go over here shortly. So for those that may not know what exactly a service connection looks like, or what we are at ADEQ focused on when it comes to lead and copper, a lot of materials are comprised in a drinking water system. We have water mains, we have meters, we have curb stop boxes, we have service connections, goosenecks, and then we get into premise plumbing, and there's a lot of different water components in of itself along those schematics. Sources of lead, and I'm focusing more on lead because that's the precedent of in the public health aspect that we think about, not so much with copper when it comes to drinking water tap results, really can come from a variety of different materials and components. Anything from brass or bronze fittings of water meters, valves, solders, joints, faucets itself, all can contribute some sort of lead release given certain parameters, such as stagnation time, the oxidation reduction potential, fluctuating pH changes. Those sorts of things are all indicators that we look for to help assess how lead and copper are corroding into a tap. Other factors for metal release, physical disturbances, such as disrupting water lines, water line constructions, not flushing appropriately. Those are significant factors in what can cause a metal release, particularly from a scale perspective. Hydraulic factors such as water line breaks. Anytime you lose pressure in your system, you're taking the chance of different biofilms and scale along the pipe that has layered and being disrupted, and therefore lead scale breaks off. Water usage, which is a lot of what we see and what we end up deducing in Arizona when we look at our water systems who could or may have lead or copper issues. Excessive stagnation, and especially during this COVID times, some of our schools, some of our campsites, RV parks, those are some typical water systems where we're starting to see higher lead results come in. So, you know, the same types of information we give water systems to prevent Legionella from occurring, flushing and moving your water is the same type of information we're giving to our water system to also lower the impact of lead and copper release. And water temperature also has a very big component into metal releases. So understanding corrosion. Corrosion is a reaction between metals and the water, and there's different types of corrosion that can occur, and those types of corrosions help paint a better picture for us that then ends up resulting in a better corrective action or a better treatment process for that water system. Typically, corrosion, it is an oxidation reduction type reaction on the metal pipe. Mostly, I think our state, when we really try to break down some of the results that we get in, what we see most of the time is it's a lead particulate, which tells us that a scale broke off versus dissolved. When you start seeing dissolved, that's an indicator that the metal is directly in contact with the water, and that's not what you want to see. So different types of corrosion on metal surfaces. Galvanic is a very big one. That is where you get the cathodic reactions, galvanic cell reactions, where cations and anions want to give themselves up. Particularly, we get concerned when we see partial lead service line replacements where, you know, maybe a galvanized pipe was connected to an existing lead service line. And that's an indicator that some galvanic cell reactions are going on because you have different metals connected with each other. Pitting or localized corrosion is also a type of corrosion that occurs on metal surfaces. If you can see, there's little pieces missing, little nodules. That's an indicator of a certain type of corrosion going on. Uniform corrosion is where we typically see, if we see a lot of dissolved metal and not a metal scale, then that's an indicator that uniform corrosion is going on, and we have a complete metal to water interaction. And more recently, we're spending more time understanding how microbially induced corrosion could be impacting a water system. Bacteria, it gives up enzymes. Enzymes end up being acidic. So the acidity nature of enzymes emitted from bacteria end up touching these metal surfaces and touching these lead scales, and therefore causing release of these metals. So it's a lot of investigative work when it comes to a water system exceeding their lead or copper action level. Corrosion control in of itself is very sensitive to water chemistry. And water chemistry has a significant influence into helping us understand what is impacting the water system from a lead and copper corrosion perspective, but even from a preventative perspective. Up until the short-term revisions in 2016, when Arizona adopted those, water systems did not have to report to ADEQ if they were doing any long-term treatment changes or source water changes. But since those rule requirements, now we're able to take a more proactive and preventative perspective and looking at some of these key changes, such as disinfection profiles, filtration profiles, and just the overall chemistry profile, especially if a water system's changing their sources from a groundwater into a surface water source. Scales for us, and anyone who is required to adhere to the Safe Drinking Water Act and Lead and Copper Rule, helps us really see a picture of what's going on with the system and maybe even the water chemistry and water use over a system's history. So ideally what we want to see is passivating scale form on metal surfaces. So this is when we get a uniform film formed on the pipes and the water reacts directly with that passivating scale. Deposit scales are when substance and water participate buildup on metal pipe surfaces, and they're not so readily formed in a smooth fashion or in a uniform fashion, and those deposited scales are more at risk from breaking off when there's hydraulic disturbances, pressure loss, or physical disturbances. And those break-off pieces end up going through people's taps and out through drinking waters, the drinking water glasses. So here you have two different pictures of pipe classification schemes. On your left, you see scale forming, which is a corrosion scale. Typically, we can see this with unlined, cast or duct down iron pipe, steel and galvanized. You're not getting a very uniform type of scale forming. Non-scale forming, we get concerned when there's a lot of asbestos cement pipe used in the materials inventory or plastic or cement line. It's very hard to get that scale onto those pipes, and therefore you have a direct metal to water relationship going on. So overview of health effects for lead in children. Lead cations specifically become an issue for children in their developmental stage because where lead is readily available in the body at the synapses, the child's body will choose to uptake those lead cations where calcium is typically absorbed. And then that's when you start getting neuromuscular dysfunctions, among other issues related to elevated blood levels in children. So like I mentioned before, there is no reference dose or toxicity value determined by EPA and under the Safe Drinking Water Act. But what we do know and understand is there is no tolerance for lead exposure. And the higher exposure that can happen, the more increased risk for adverse health effects, especially for those that are a susceptible population. Copper is a concerning exposure, particularly for those that have complication of Wilson's disease, which is a genetic predisposition, and it can cause excessive liver disease in people that do have complications of Wilson's disease. Those that have Wilson's disease, they're unable to metabolize copper, and therefore it has a lot of uptake in their liver. So looking into the applicability of the Lead and Copper Rule under the Safe Drinking Water Act, and who does this apply to? So under the Safe Drinking Water Act, we have 3 different types of water systems, and 2 of those 3 types of water systems are required to monitor for lead and copper at their taps. We have non-transient, non-community water systems, which are typically water systems that serve the same people for more than 6 months out of the year, or the opposite with the community water systems that are serving the same 25 people year round. Population under the State Drinking Water Act for the lead and copper rule has an impact on their rule requirements, their sampling frequencies, and reporting requirements to ADEQ. Under the State Drinking Water Act, particularly for the lead and copper rule, there's 3 different size water systems. We have groups of large water systems, those serve more than 50,000 people, medium-sized systems that serve less than 50,000 people but greater than 3,301, and then our small water systems under the lead and copper rule, which serve 3,300 people or less. Another group for us that we look at now is any of the water systems that start going over 50,000 people, and we call those newly large systems. And then they're introduced into a more stringent set of requirements under the lead and copper rule. So getting into some of the proposed lead and copper rule revisions compared to how we regulate our drinking water systems today. So EPA's lead and copper rule includes a lot of actions that are going to help reduce lead exposure in drinking water. There's a lot of focus into lead in school sampling, which is what I'll end up talking about towards the end of my presentation. The proposed rule is going to help identify more at-risk communities and ensure that there's more action plans in place, such as having on standby a lead surface goal replacement program and also a corrosion control implementation plan ahead of exceeding that action level. Some of the key focuses and areas for the lead and copper rules long-term revisions, like I mentioned before, is identifying areas that are most impacted. As a regulator, it's helped give us more rules to help strengthen treatment requirements. There's now mandatory lead service line replacement goal programs that those water systems who have identified lead service lines have to have a program and a plan to start implementing lead service line replacement if they're initiated into that. There's more reliability around the sampling aspect. Every water system now is going to have to go back and either redo or reevaluate what we call materials inventory. So they're going to have to very, in a minute way, find where the lead is in their water system. And one of those challenges that they're going to be seeing, and particularly you guys might be hearing about, is now the rules requiring that they understand what's on the customer side of the service connection. And that's very foreign to our public water systems. Typically, water systems are only held responsible up until the meter, and everything past the meter ends up being what's the customer's responsibility. Risk communication has a lot of enhancement in the long-term revisions. There's public education, expedited requirements, and among public health department reporting on top of reporting to those who have primacy and jurisdiction over the public water systems. So like I mentioned before, large systems hitting the same definition if they serve more than 50,000 people per day. And I also mentioned before that they're held to more current stringent lead levels, which is what we call the PQL. So currently, water systems are held to the 90th percentile concentration, meaning that if 10% or more of their samples comes back above the action level for copper, 15 micrograms per liter, or 1.3 milligrams per liter for copper, it requires and it triggers them into what we call the corrosion control treatment steps. And in the proposed revisions, what EPA is currently proposing is now there's going to end up being a trigger level. So once a system's 90th percentile for compliance tap samples exceeds 10 micrograms per liter for lead, that's going to trigger them into doing additional planning, monitoring, and for those who may already have current corrosion control treatment installed, that's going to require them to re-optimize their system to bring those lead levels back down in order to prevent them from having a lead exceedance. Trigger levels in this case are not going to be applicable to the large water systems. Like I mentioned before, they're held to something called a PQL or practical quantifiable. For lead, that is 0.05 milligrams per liter. So their 90th percentile is held to a very stringent number and very tight number compared to that 15 micrograms per liter. Stat monitoring results will be looked at and evaluated a little differently under the proposed revisions. Currently, there is no regulation that requires us to emit samples for a water system if they take more than their minimum requirement, as long as it's done within their monitoring period. This is one of the biggest key changes, I think, for a public water system for the proposed revisions, and it helps close some loopholes. It's a statistical number for a water system to meet or become below their 9th percentile calculation. For the long-term revisions, if a system takes 20 tap samples, the compliance is determined off of the highest 20. So if they end up collecting 30 samples and the lab analyzes 30 samples, only 20 of the highest concentration results will be counted for their compliance. Additionally, if systems have lead service lines, they have to include all lead service lines in their sample results, where before, with the current lead and copper rule, only 50% of their samples were required to be sampled from lead service lines. Collection procedures will also change post-Flint, actually pre-Flint. A lot of the sample bottles that were used to collect lead and copper tap samples were not wide mouth bottles. After Flint, an EPA memo came out, highly recommending that water systems move towards using wide mouth bottles in order to get a better representative flow coming from a faucet into that sample bottle collection. Additionally, before a lot of the Flint investigation and understanding the bias in the sampling, a lot of systems did what was called pre-stagnation flushing, that they would flush the lines and the lines would sit for 6 hours, and we would only get a representative sample of what that water interaction with the pipes or scale may be within a 6-hour time period. So that was also part of that same memo that instructed water systems to start using wide mouth bottles. But under the proposed revisions, both of those sampling requirements will now be in rule. Additionally, under monitoring and frequency, there's going to be right now, when a monitoring period changes, both lead and copper analytes are put on the same monitoring frequency, but under the proposed revisions, if a water system stays in compliance with the copper aspect of the rule, then they could stay on what's the most reduced frequency, which is triennial monitoring. And they could also be put on 6-month monitoring for lead. So there's going to be a little bit of difference in how lead and copper are analyzed, where the current rule analyzes the compliance for lead and copper simultaneously, regardless if one analytes in compliance with the action level and the other one is not. So getting into corrosion control treatment requirements, like I mentioned before, typically our large systems are systems who are implementing and treating their water with some sort of corrosion control treatment technology. A lot of our smaller systems or medium-sized systems, they're only subject to corrosion control treatment requirements if they've had an action level exceedance. With the current rule, if a system monitors for 2 consecutive 6 months and they have no action level exceedances, they are allowed to cease their treatment step milestones, and therefore that ultimately could mean that they did not install their corrosion control treatment. So there's kind of a first pass, not a first pass yield, but there's the opportunity for a system to not have to install corrosion control according to the current rule if they do have 2 6 months of no action level exceedances. The significant change with that in the proposed revisions is now, regardless of the size of system, if you have 1 action level exceedance of your 90th percentile above the lead action level, you will have to install treatment. And that's going to be a big burden on our state, especially for our smaller water systems. For me, working in our technical assistance program, the small systems that I help with end up only serving sometimes only 100 people. They're very, very small communities, but we'll get into a couple of their compliance options in a few slides, other than just installing corrosion control treatment. So water quality parameters is a big sampling indicator for us at ADEQ to help us understand what's going on from a water chemistry perspective. EPA is proposing that systems who serve more than 50,000 people have to do regular water quality parameter monitoring regardless if they're installing corrosion control treatment. And that's really different from what's happening right now. In the current LCR, water quality parameters is only required to be monitored if they have designated corrosion control treatment or after an ALE, which kind of can be an issue for us. So as we're seeing what's going on from a water chemistry perspective way after lead and copper releases start happening. Like I mentioned before, one of the big burdens that we're trying to be conscious of in our state when it comes to the proposed revisions is our smaller water systems. And they typically are in the more rural parts of Arizona. Fortunately, under the long-term revisions, there is a small water system compliance option. Those three options end up being the system would have to install point-of-use devices at every service connection and at every tap that's typically used for human consumption. Those would typically be your kitchen faucets and your bathroom faucets. The system could have the option of just installing a corrosion control treatment and having a uniform treatment option throughout their system. And if the water system owned 100% of their plumbing materials, such as a school, and in Arizona we have a lot of schools that are also their own public water systems, and hospitals, they could try and replace that material, do some follow-up sampling, and demonstrate that they have corrected that lead corrosion issue by a material replacement aspect. Something new under the long-term revisions that ADEQ is anticipating right now and working through is the sanitary survey aspect. So sanitary surveys is our what we call our inspections, our field inspections from our inspection staff. Under now, the current rule, treatments is not a requirement to be reviewed, particularly from a water quality parameters perspective in the field. The only time a treatment really gets evaluated is if a system reports that they're outside of their parameter ranges from their treatment plant, which ends up giving them a treatment technique under the lead and copper rule. So the proposed revisions will have a tighter control under their current corrosion control treatment and water quality parameter data review. So ideally what this would look like is our inspectors working more closely with our water systems out in the field and evaluating their water quality parameters and whatever pH ranges, corrosion control inhibitor dosing, and trying to see if there might be some ways to tighten those controls, particularly if they're starting to see results outside of their ranges. One new aspect that we are going to be seeing is something that EPA is coining the find and fix. So find and fix has a lot of different ways to go about identifying where lead sources are. But at any tap sample result that shows above the 15 micrograms per liter for lead, a water system at a minimum has to start collecting a follow-up sample at each of those locations. They also have to conduct water quality parameter near the site that had the lead exceedance above 15 parts per liter. And they also need to perform corrective action. This is going to become a burden on our water systems. So again, a lot of what could happen, a lot of the corrective action could be past the meter and not an area or that a water system would have jurisdiction of. So there's going to be a lot of collaboration between working with DEQ's drinking water program or technical assistance program in our drinking water, particularly with local health departments, homeowners, and water systems, and trying to get this corrective action resolved if this still stays the language in the final revisions. So what are some of the ways that a system can look at implementing find and fix? So one of those ways could be through sequential sampling. Sequential sampling, in a nutshell, is a series of samples taken after a specific stagnation period. So you are going to do pre-stagnation flushing when it comes to sequential sampling. Typically, we have water systems flush their line, and the water stays in there for a 6-hour window. And these are smaller incremental bottles, sample volumes pooled over time. And what it's supposed to do is help us identify the lead source. So if we see spikes, at sample bottle 3, a material or a water system component at that point is the indicator that maybe the lead's coming from there. We also analyze using cross metals such as tin, because where we see lead and tin together, it ends up telling us that it most likely might be a brass and bronze fitting that's causing the lead to be released. And therefore replacing that fitting with something that's what's considered lead reduced or lead free may result in that tap not having higher lead levels at it. So here's just another schematic of a find and fix solution through sequential sampling. So you have the tap at that little kind of gold upside down J shape. And each one of those points is a sampling point. We see S1, S2, S3. Then ideally, when we sample those in smaller incremental bottles, and after they're analyzed and interpreted, we're able to identify at what point we feel the lead is coming from, then doing a field verification along that line, just to physically seeing that component, and then suggesting and recommending that component be replaced. For the most part, what I've seen where water systems implement this type of sampling, they're really seeing the higher results happen at S1, S2. And it ends up being that the faucet fixture itself is not considered NSF, following the NSF lead-free protocol. So we ended up recommending either they replace the fixture or use a NSF 61 ANSI certified lead filter for reduction. This is just ideally when you do use sequential sampling, how you're going to graph out your results and looking at the peak concentrations of lead. So this came from an EPA peer-reviewed and published article as an example of what we use and what we look at. So you're cross-referencing the type of plumbing material at the very top with the blue line. You have copper, galvanized, copper, low service line, and then unknown. So you can see with some of the peak lead concentrations along the black line, that unknown part was releasing lead. So therefore it could result in doing a little excavation, digging up just to see and do a scratch test, a magnet test, those sorts of things to confirm what type of material that unknown aspect is. Okay, so getting into the lead service line program activities under the current rule versus proposed rule. I've been working under lead and copper rule for about 5 years with ADEQ's drinking water program, and in very, very, very few systems, and there's only 2 I can think of at the top of my head, have reported any lead service line inventories. So for the most part in Arizona, I feel pretty confident, pretty safe to say a lot of our lead issues ends up coming from different lead components, such as maybe goosenecks, maybe solder fittings, brass bronze fittings, faucets, and those sort of aspects. But for those systems that do have lead service lines, they do have to identify their complete inventory within their first 3 years of the rule becoming final. Once they have that lead service line materials inventory identified, they do have to develop a plan to implement any replacements depending on the 9th percentile concentration. So I mentioned before, there's a trigger level of 10 parts per billion or micrograms per liter that a system's going to be held to start becoming proactive and preventative of exceeding that 15 parts per billion of action level. One of those aspects could be starting a kind of slower route of lead service line replacement. If they happen to exceed the 15 parts per billion action level, then there's an expedited lead service line replacement program they'll have to implement. And I stole my next slide. That's exactly what I just summarized. Lead service line related outreach. Right now, when a system plans to replace a portion of that it owns, it has to offer the replacement on the customer owned portion at the owner's expense. Again, this is a very challenging and controversial topic that at stakeholder meetings we have with our water systems, where a lot of the responsibility in getting the outreach and lead service line replacement does fall on the water system to incentivize the homeowner. Also, part of the lead service line program, water systems have to have public education material ready to go and ready to be implemented. This is a newer requirement. There also has to be and will be more public education and health outcome, not health outcome, but drinking water reports that are not only be required to submit to ADEQ, but also to the local and state health department. Once we have the permission to start the rule writing process in the state after the revisions happen, a lot of those that are online are going to be key stakeholders and key partners into what this part and what this implementation of the health department reporting looks like. Last but not least, lead in drinking water at schools has become a very big topic over the last several years, and particularly after Flint, Michigan's lead and copper issues, among other water quality issues. So right now, the lead and copper rule does not require any testing at schools unless the school itself is considered a drinking water system and therefore has to adhere to all of the Safe Drinking Water Act. Under the proposed version, any community water system that serves a school, K through 12, or any licensed child care facility will have to sample 20% of those schools each year over 3 years. So all of those sample results and public education has to be provided to each sampled school or child care facility, not only to the primacy agency, but also to the local and state health department. So also under the proposed revisions, what it does expand requirements to any system that has a 9th percentile exceedance will automatically have to go out and start sample lead in schools. And it does also require them to start looking at their corrosion control treatment status, re-optimize, or off of those lead in school samples as well.